Thank you for the nice introduction. My name is Bernhard Nußbaumer. I'm Business Development Officer at ACMIT, the Austrian Center for Medical Innovation and Technology. And today I will first introduce you what we do at ACMIT. And in the second part, I will show you an example how we bring new technology into medical devices to improve medical innovations. So, who we are at ACMIT? We are a non-profit research and development organization in Austria, situated next to Vienna in a science park. We offer services from the idea to the clinical use of a medical device. We have an ISO 13485 certification, so everything what we do in our center is documented that you can use it for the technical file, bringing to the notified body to get your certificate afterwards. We work together with about more than 60 partners coming from scientific side, so hospitals, universities, but also company partners. We offer attractive conditions because we have public funding. We also offer contract manufacturing, but limited of medical devices, but limited to small series. And we also an incubator for medical technology startups. Why are we doing that? Because we found out that if you want nowadays have the real good ideas to implement technologies to help people, then you can't go to the corporates anymore because they just do it like that. They screening all the startups and waiting if there is some good idea, and if it's okay, if they reach a market, then they buy them. And so we also started to address startups. So from the services, we offer the complete process chain from the first idea to the clinical use. And let's say the topic is we have everything is about digital health-driven therapy systems. So we have some, let's say, special expertise from the technology side. This means we have optical experts. We in the fiber optics, for example. We have experts for other sensor systems. We have experts for robotics, for robotic-assisted surgery, and also one topic is workflow, optimization of workflow, analysis of clinical workflows, and bring this after all to a more efficient way. We think that not only for other products, but especially for medical products, it's very, very important to have the eye on the usability. So this is why we have a, by the way, for medical technology product, for medical devices, it is obligatory that you do a summative usability test. But I think you should even do more, because the market success of a product always strongly relies on the usability of a product. And this is why we have all set up to do this usability engineering studies in our house. We have an experimental OR, and we also have video setups where we can observe what the problems are doing. So what are our incubator services? We focus on international medical startups companies, mainly on early stage. We help them from the first start until to the product on the market. We offer co-financing, so up to 50% of our costs we can cover ourselves. We give the complete IP to the startups. We don't take any shares. And we have a model that is based on the revenue if they are successful in the market. Of course, this involves some risks for us, and therefore we do some due diligence, but it's a very fast one, so within a few weeks we can decide whether this startup is good for us or not, can be financed or not. And, as I told you before, we also offer contract manufacturing, and this is very important for medical technology startups because they have always the big problem that medical technology is a big effort, also the manufacturing, so it doesn't make sense from the beginning that they build up their own manufacturing sites. on the one hand, but on the other hand, it's not that easy to find an external one, because the big ones, they always want to have high turnovers related to the risk they have to if they cooperate with such a startup. So we close that gap and help those medical technology startups in these early phases to ramp up their production until they are successful in the market. We offer them small series production. When we work together with those startups, we, let's say, design the development process so that there are different milestones where different types of investors can invest into that startup. So we prepare everything, for example, someone in early stage who wants to see a demonstrator, TRL5, or wants to see a clinical study, or wants to see a CE mark, or already wants to see already devices on the market. And we do it like that, and we also support with the intellectual property. So is there any intellectual property? How can you protect it? How you should protect it? We support with the business planning. We offer a network to investors and to funding bodies. And we also support with the quality management systems. Because after all, if a medical startup wants to go to the market and wants to sell products, he needs to have his own quality management system. And this is quite an effort. And therefore, we have some kind of a base documentation, which we can hand over them. And either they do implement it then by themselves, or we can even support them to implement it. Based on all the services, we have already about, let's say, 10 different products on the market, which are in medical use. Let's say the most famous one is our neurosurgery robot that we developed together with a startup company, which was then sold to Medtronic, and is now, since 2019, available under the brand of AutoGuide at Medtronic. Another thing is what we do. We have a virtual autopsy system where fully automated, the guys in Zurich, for example, can do forensic testing of, if there are criminal examinations. They can completely virtual examine the cadavers, the dead bodies. Another example is we do intraocular lens design, so the multifocal one. And another interesting example is that we developed, let's say, an add-on for a classical 2D ultrasonic system to pimp it up to a 3D ultrasonic system. So a doctor can just pimp its normal system up to a 3D and can do all what you can do with a 3D-based system. So now I tell you an example, a current example, how we bring in new technologies into medical applications. So if you look at a conventional endoscope, it's old-fashioned. I would say it's classical optics. It's the sensor and optics is outside the body, and you have a good picture quality, of course, because you have up to 3 CCD chips for each color. You have a chip. You have an optional optical zoom, so you have real good picture qualities. You can change the focal planes and can zoom really good, but you have limited miniaturization. So the next step, what in the last years was done, was there were built chip-on-tip endoscopy. You have also quite high picture quality there, so up to 4K, 2K. You have an integrated optics, but you have a fixed focus there. So either 2 up to 50 millimeters, you have there some fixed focus. And there is no optional optical zoom or focus adaptation available, so you can just do digital zooming. And this was possible, of course, of the development revolution of the chip size. So the smallest CES chips nowadays are smaller than 0.6 millimeters. But now, as I mentioned before, now you have this small endoscope, but you have no possibility to change the focus length. So you have to decide, you want to in 5 centimeters away you want it sharp, or you want it in a near distance, or somewhere in between, but not over a bigger distance you have a good picture quality. Therefore, we said, okay, how we could do that? And said, okay, what we are doing right now is already we have a patented technology which is used by one of the biggest suppliers of intraocular lenses. It's Rayner, a British company, where they offer intraocular lenses with 3 focal planes, so trifocal lenses. So this means that you, after surgery, you don't need any glasses anymore after cataract surgery. And okay, how could we bring in that technology into an endoscope, into a chip-on-tip endoscope? So what we did was we just bought in the catalog a standard chip-on-tip endoscope, cheap one, industrial one, not that small, but just to prove the concept, say, okay, we bring in diffractive optics into that existing endoscope, and let's see what happens. And it turned out to be, we used an optics where we had a bifocal optics with at 2 millimeter was one, so in the near, and in the far at 25 millimeters. And as you can see here, on the picture, on the right one is the bifocal one. It's a clearer picture, even in the near, compared to if you just have a monofocal, where it's optimized in 25 millimeters. But there would be, of course, also even a bigger effect if you would have the far in 50 millimeter distance. So, of course, then the difference would be much higher. You can also see it here on the video if it works. Yeah. So it goes from far to near. You can see how the sharpness changes, and if then you come to the bifocal one on the right side, even in the nearer distance, you can see a better image than just having it monofocal. And even this let's say, quick and dirty concept, functional prototype, we've seen, okay, this seems to be possible to bring in a benefit by using that kind of technology also in the endoscopes. So, outlook is that you can create with this technology additional focus planes from near to far view. You don't need any zoom optics, moving parts, and of course they need space, they're big, they need energy. All things that you don't want as an engineer. And you can easily integrate it in also in existing designs, because you just have to adapt the optics. You don't need more space or something, or additional parts. And after all, if you do it in high volumes, it's also quite cheap how you can do it. Thank you for your attention.